Life on Mars, where we're going to find it first and where we're going to find it most. That's the answers going to be brought to you by this host, providing, of course, it exists at all on Mars. But panspermia is a very interesting concept that lends to the idea that we just may very well find life on Mars. In fact, the oldest rocks on Earth, it seems, as soon as rocks cool down on Earth enough that they aren't molten, there's life in them. We find evidence of single cell life, little organisms in these rocks. And of course, now they found something that they claim to be conad bacterium. They say could survive for 280 million years in suspended animation and be reanimated. So there's plenty of suggestions for life on Mars, but there's two different areas where I think it's most likely to find it. We're going to find it first and most. I'll go into that in just a second. But think about this. The panspermia concept is such that even if life only originated on Earth, it could have got to Mars. But this whole thing, every little cell is as complex as New York City. Yeah, okay, New York City, I get it. But the complexity is really off the charts of a single cell organism, even the simplest ones, even the proteins that make up the amino acids that make up the DNA and everything else. The proteins themselves, they have to be folded just right. And their folding is incredibly complex, incredibly complex. The fact that life appeared on Earth so fast is amazing. It's miraculous. It speaks to something maybe out of this world. Maybe life came from out there, the panspermia concept, or it may have been created here. You know, it's interesting, but still, we may be brethren to any life we may find on Mars or without the whole galaxy, because Earth gets pummeled by big asteroids and chunks gets blown off, and Earth goes all the way around the galaxy about every 250 million years. If the Earth was the original spot of life, it may have seeded the entire galaxy. We may have a lot of distant cousins out there. We may all be kin. Maybe, maybe not. And then again, we may be the sole only living world in space. Now, I know a lot of people will reject that and get mad and say, that's ridiculous. But, you know, this is the only place that we know for a fact that so far we can prove that life exists. Prove. Oh, yeah. Woo doo 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 doo. All these little things flying around. Where do they come from? Here, maybe? I got a video on that. Suggests they don't come from out there. But, you know, hey, that remains to be answered, whatever that stuff is. You know, DOD is beginning to think it's spies from other countries. Oh boy, I tell you, if they're that far ahead of us. That's another topic for another video to come soon. Okay, so let's get into this, guys. Let's have a look-see at some of the new evidence coming out that suggests ample opportunities for life on Mars. And given that and how fast life come on Earth, and that Mars had an ocean, I suspect it's still there and may have originated. Well, I'm expecting we're going to find life on Mars. So let's have a look where. Okay, here we go, guys. Not a year ago, on the 24th of December, Christmas Eve 2021, there was an impact on Mars that caused the InSight lander on Mars to actually experience a 4.0 Mars quake. And so that's pretty jarring. And this is what came out of the crater where this impact occurred. All around is ice, chunks of ice, chunks of water ice all around. Now, this doesn't necessarily suggest that there's a layer of ice in here. Rather, it seems to be mixed in with the soil, and that kind of fits because Mars gets so pummeled with so many things from space over time. Look at all these little bitty craters. So this soil gets tilled by impacts. Yeah, tilled. And so it's more regolith, like what you find on the moon. Regolith is just busted up rock, you know, like little tiny shards of glass. That soil is nasty. Now, maybe Martian soil is weathered by the wind, so it may not be that bad. But weather on Mars isn't like on Earth because you still have craters that are way older. You know, features don't weather away there. But that's another story. So let's look at this ice. If you got ice here on the surface, this makes a suggestion that as the Martian temperature goes up and down at times, under the surface, some of that may melt. And in fact, we see evidence of that. Here's a crater wall that has a little water dribbling down the side. Now, this isn't going to last long because Mars' atmosphere is only 1/100th as thick as the atmosphere on Earth. It's practically a vacuum. And because the pressure is so low, water will, even ice will sublimate into the atmosphere, water will evaporate, basically it will boil real quick. So water cannot last long on the surface of Mars at all. Any water that's liquid would be gone in a hurry. Even water ice cannot last too long. Just think about your freezer, how ice can sublimate over time. And you have humidity and strong pressure, but on Mars it would go a lot faster. So that's why you find it under the surface, not on the surface too much. And you got at the poles, you got carbon dioxide frozen and the polar ice caps. There might be some water mixed in with that, but it's mainly a COT phenomenology from what I've heard, dry ice and so forth. Now, if somebody knows better, say so in the comments below. Okay, but water. This is liquid water on the surface of Mars, which suggests that under the surface, where all that ice is, you have periods where that ice intermittently melts and thaws. Well, that's a perfect location for bacteria to form. Mars finds evidence of water. There we go. And bacteria like this little guy, whatever this is, Conadibacterium. This guy that supposedly can live for 280 million years inactive in suspended animation. That's why they call it Conadibacterium. So they think bacteria like this, extremophile bacteria, which can handle radiation and such forth, could actually survive on the surface of Mars, near the surface, just under the surface of Mars, right in this area where you have indeed an interface between frozen and maybe temporary liquid water from time to time. That may be a place that you would find life. And if you find life on Mars, that would probably be the first place you find it, but not the most. We're going to look at the most in a little bit. There's all kind of evidence of Martian ocean, river deltas on Earth, river delta on Mars. Of course, the craters. Mars has got more craters. The atmosphere has been thinner and longer. Craters. Not like the moon quite, but pretty close. But Mars has some weather, but not as much. I mean, one time, Mars probably had a lot more weather when it had water like that. And the atmosphere would have probably been a little thicker than this rendering seems to indicate. But yeah, one time, this is what we believe. We're finding evidence of an ocean on Mars in many different ways. Some of the recent findings have been the shoreline of the ocean. Now, the scientists believe that Mars has a liquid iron core, which means as you go down in Mars, it's still hot. Not only that, the mantle on Mars is only half as thick as a mantle on Earth. So there's actually a very large core on Mars proportional to the planet. So it's kind of interesting that Mars doesn't show real active volcanism on the surface with a thinner mantle, and there's still a big core, which is still apparently liquid. But it also doesn't have a magnetic field. Probably hasn't had a magnetic field for a very long time. And that's why the atmosphere was not protected from the sun and got stripped away. And Mars lost its ocean, and whatever critters might have been crawling around on Mars didn't survive long on the surface. Maybe there's some just under the surface. So Mars was once a very interesting place. Now, people talk about terraforming Mars, but you put a lot of effort into an atmosphere, and you're going to lose probably all that material over time as you find some way to protect it. Now, here's where I think here's what's the hint is. You got heat here. Here is heat. Aha. There's water in the crust, and on Earth we're finding maybe more water underneath than on top. There's some level down here where we've got even more water. On Earth, if you drill, there's mines that go 2 miles deep in South Africa for diamonds and things like that. And guess what? At 2 miles deep, you can't stand the heat on Earth. With a larger core on Mars, you probably couldn't go any deeper than 2 miles on Mars either. The fortunate thing, that 1/3 the gravity of Earth, the structure shouldn't be as it should be more resilient to cave in. It shouldn't be easier to build structures that won't cave in on you. You'd reinforce them, but it should be easier on Mars than Earth. So boring down on Mars might be very interesting. Other than you might drill and hit water. There may be an ocean under Mars, liquid water. This is where I expect the bacteria will be the most. This is where you're going to find the most life on Mars. Would be deep down where it's warm enough for the water to be liquid, should there be such a thing. Now, we don't know this for a fact, but just knowing what we know about Earth, the conjecture that Mars had an ocean, and then we know it's got a hot spot down in here, that's interesting. Also, it's so cold on the top and so hot down here, you could build some heck of a heat engines going between, drilling down a mile deep maybe, and also hit water and different things and resources. So Mars could be really interesting for that area if we don't get contaminated by some kind of bacteria. I got reasons not to worry about that though. But look at this, guys. On Earth, this is talking about the subsurface deep biosphere. This article, paper, Geological Society publications here, suggest that it's 1/10 to 1/3 of Earth's total global present day biomass. If you look at the mass of all the plants and animals on Earth, the stuff living deep under the crust by this study is claimed to be 1/10 to 1/3. Well, I have heard many times it was actually more. Is it? Here's an article that says it is. Life in the crust, the Earth's biggest ecosystem, and its implications. So this is an article. Of course, this isn't a scientific paper, but there's plenty of papers that make such suggestions that there's abundant life deep in the crust of the Earth. So I'm stop the share. Halo, wow. So that is where, if there's life on Mars, I would expect you would find the most of it. Now, that kind of life is different than life on the surface because it lives on different chemicals. It doesn't live on photosynthesis. It uses the minerals in the rock and the heat from the rock kind of to metabolize. So now bacteria closer to the surface might be different, but still, anything living underground on Mars, I have a hard time thinking it's going to be metabolizing based on eating living organisms, so like us. So the idea that we get infected by it, it's probably remote, very remote. Because when you think about it, we have tons of soil bacteria on Earth, lots more, because the surface of Mars is actually pretty sterile, very sterile. So I think the chances of us getting contaminated by something there is minusculely small, diminishingly nothing to nothing. But it's existent. It might be the Andromeda strain that will wipe out anybody that goes there. I'm thinking that's not the case. That's a really spooky thing to contemplate just before Halloween, right? Andromeda strain on the subsurface of Mars eats everybody. And all that's left is Tesla's cars. This is electric cars buzzing on Mars. Now, the interesting thing is that Tesla came up with an electric car, which is perfect for Mars, not maybe in the current form. It's Tesla Cybertruck, because you can't have internal combustion engines. We don't have an atmosphere. But the Boring Company, what I talk about, boring tunnels, you can build some amazing habitats on Mars. Get down under the surface, well under the surface, where you're protecting the radiation. Get down there where the temperatures are more stable, even on the moon, which goes from minus 250 to about 250 above Fahrenheit. Those lava tunnels have temperatures kind of like Earth, about 70 degrees in them. That's what we're seeing. So if you bore down on Mars, you're going to see something similar, a nice stable temperature. So you can establish a habitat and adjust the temperature. If you need heat, drill down. If you need cooling, pipe up. Radiate out top. It's cold on the surface of Mars in most places. Yeah, very cold. So, and that's a good source for maybe a heat engine on Mars. Maybe you don't need nuclear plants. Just tap into the difference between the core or the mantle down a little bit and what's above. Of course, that's a lot of drilling, but maybe not as much on Mars. It may not be as bad where the gravity is less. I don't know. There's a lot to be determined there. I don't have the answers to that, but I know the possibilities are interesting. Very interesting possibilities what can be done on Mars. So, yeah, you might have an Andromeda strain. I'm expecting bacteria to be there. Now, we're going to bring our bacteria with us. Will they eat that stuff? Well, the Earth bacteria hasn't wiped out the bacteria living in Earth's crust, and it probably can anyway. They're probably cousins. So, I don't think life from Earth is going to wipe out Martian life. That's part of the conundrum. People say, well, we can't contaminate Mars because we've already contaminated Mars. We've already landed so much stuff there that we've already contaminated it. So that's already passed. Of course, we'd contaminate more as we take more stuff up, I suppose. But we're going to bring life to Mars. We'll bring Mars alive for real, big time. So the most life on Mars might be in that ocean underneath the crust, or it might be the parties held in the habitats of Elon Musk. We will see in time. Let's hope we have plenty of life on Mars, Earth life, and whatever's there. Let's hope that we don't wipe it out either. But like we haven't wiped out the bacteria in the crust of the Earth or the soil bacteria on Earth. So if there is bacteria there, I expect it will survive. And I don't really think it's going to impact us. Ah, well, maybe we should quarantine people once we go up there for a little bit. Anyway, I think it's going to be fine. So I look forward to the day that we go to Mars. You know, when the whole world looks like me looking through these rose-colored glasses. Do, 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 do. Okay. Thank you guys for watching. This is Greg Allison with Galactic Greg. Subscribe, bang the notification bell, and click all. And there's the video I'm going to show you up here on panspermia. Check it out. Check out the banner. And thank you for watching. Greg out.